I'm Steve Madera, Vice President of Global Thermal Sales for the Vertiv business. It's really being driven by a lot of AI applications and machine learning applications that are evolving. It's now requiring higher density processors, and in many cases like supercomputers that are closely connected. This is impacting the cooling solution. Where there are air-cooled servers that are doing this, we're seeing the need for rear door applications and for maybe small pods of equipment that are cooled. And we're also seeing the advent of liquid-cooled machines that now require you to bring some sort of cooling liquid directly into the chip of the machine. So when we look at liquid-cooled machines, we're really seeing two types. One is where we're bringing a fluid or a liquid to a heat exchanger that sits directly on the chip or the processor within the server, and it's taking out probably 60–70% of the total server heat. The other method is to fully immerse the server into a dielectric fluid that will remove all of the heat out of the server. With liquid-cooled servers, you have several more opportunities to incorporate free cooling. Because instead of a server needing 70 to 75 degree air entering the server, you really are cooling the chip or the processor, and it really needs to just cool the junction temperatures, which could be over 100 degrees, so I need to bring a fluid in 9,500 degrees or even possibly higher. And that allows me to reject the heat much more easily to the outside environment. So this will have a pretty big impact on the data center design. If I'm an air-cooled or a non-chilled water data center, I need to now figure out how to bring liquid to the rack. If I'm a chilled water data center, I will probably take some of the chilled water that's cooling the rest of the data center and pipe it out to the rack. So you're going to see some changes, especially when you look at raised floor data centers, bringing piping under the floor with water. If it's a non-raised floor data center, we need to look at overhead piping and how that would be implemented. Well, we're seeing a lot of the first AI applications happen at a number of locations. We're seeing it as an example in banks, so a lot of enterprise computing. We're also seeing it in a lot of cloud companies and cloud applications. They may be in their own facilities or they may be hosted in a colo facility. So we're starting to see the evolution in both enterprise, cloud, and colo applications. I think in time, we'll see some of these applications move down to the edge computing. Customers are trying to understand timing and when they're going to need to deal with liquid cooling and high density servers. If it's just a high density server that's not liquid cooled, it's how do I, within my facility, create a pod and kind of control the heat. When it's liquid cooled, you need to kind of plan, how am I going to bring liquid out to the rack? So customers are preparing for this, and we're seeing actually in the colo market, they're anticipating their customers bringing in these high density servers and liquid cooled servers.